Okay, you ready? I just tried it and made a mistake, got stuck, so I stopped. But let's try to prove the binomial theorem, which says x plus y to the n equals summation k equals 0 to n right? Okay, we'll do it by induction. It's true for n equals 0, n equals 1, n equals 2. You can do these by hand, okay? I won't do them. You can do them by hand. Very easy to check, okay? Then we'll assume true at n minus 1. And now we're going to show that if it's true, if I know it's true for n minus 1, I'm going to prove it's true for n. And then since I know it's true at 2, or even at 1, if you want to start at 1, if you prove this step, this will prove it's true at 2. Well, if it's true at 2, this step has already proved it's true at 3, etc. We can wave the magic wand of induction. Okay, then we begin. It's not too many steps. X plus y to the n is equal to x plus y to the n minus 1, right? Plus y, x plus y to the n minus 1. Certainly, that's true. And now I can use the induction hypothesis, okay? So the left term, so let's look at these terms one at a time. So x plus y to the n minus 1. What's this equal to? This is equal to, okay, now I want to use the binomial theorem, but at n minus 1. And I'm going to have an x outside. So this gives me, if I'm looking up there and trying to write it down here at the same time, this gives me summation k 0 to n minus 1, n minus 1, choose k, x to the k, but I have an extra x outside here. So I didn't write it there on purpose. I'm trying to bring it in here. So I have x to the k plus 1, and I have y to the n minus 1 minus k, and I will bring those together and write that n to the minus k plus 1. Okay? So that is just using the fact that we assume it's true at n minus 1, and I multiply that term by x. Let's expand this a little more by changing the index here. If I'm going from 0 to n minus 1, I could also go from 1 to n in a different way. So this is equal to, and I'm just not going to fuss much with this and hope that you follow it, k equals 1 to n. I've shifted this by 1, so I have to shift every instance of k over here. So this has to now take 1 off. To get, everyone has to take 1 off. So I get n minus 1, k minus 1. Here I have x to the k, and here I have y n minus k. Okay? You can check those are the same, right? Okay, very good. Now, one more thing I'd like to do is peel off the nth term here. So what is the nth term of this sum? There are n terms. When I put n in, I get 1 here, I get x to the n, and I get 1. So the nth term is x to the n. So I'm going to write this like this. X to the n plus sum k equals 1 to, now I took the nth term out, so I'm going to go 1 to n minus 1. And everything stays the same. All I did was take the nth term out. So I have to... Okay, very good. So that's that term. You might be wondering why we're doing this, but maybe this gives you a little hint about that previous identity, and I'm sort of shaping it into the form that I want. Here I'm missing the k equals 0 and k equals n term, but things are going to work out, okay? So now let's look at the other term, y times x plus y to the n minus 1. And this is equal to, well, I have the same same thing here, only I'm multiplying a y through. So I have the sum k equals 0 to n minus 1. N minus 1 choose k, x to the k, and I have 1 y to the n minus k minus 1, or since I'm multiplying through by another y to the n minus k. Okay? And this one's in good shape already. All I want to do here is peel off the k equals 0 term. So this, I'm going to try to squeeze it down here so that I can go to the next page altogether. So this is the sum k equals 1 to n minus 1. Okay, and so all I'm doing is taking off the k equals 0 term. N minus 1 choose k, because these look nice. X to the k, y to the n minus k. And now at k equals 0, I get n minus 1 choose 0, it's 1. I get 1, and I get y to the n. So I just have to add out here y to the n. Okay, so now what am I doing? I'm claiming x to the y plus to the n is equal to these two. So it's the sum of these two results here. It's the sum of this and this. So let's flip the page and I'll write that down now. So we have okay, so almost there. So x plus y to the n is the sum of those two. So it's x to the n plus sum k equals 1, n minus 1. N minus 1 choose k, I think. N minus, I better look, I don't want to make a mistake. N minus 1 choose k minus 1. X, yeah. Plus sum k equals 1 to n minus 1. N minus 1 choose k this time. Just check. Yep, x to the k, y to the n minus k, and plus a y to the n out here. Okay, well, you see these two have the same indices, right? So I can combine these. This is x to the n plus, I have a single sum here, k equals 1, n minus 1. And I can group these two together. This is n minus 1 choose k minus 1 plus n minus 1 choose k, x to the k, y to the n minus k, and the whole thing plus y to the n. Okay, but we just proved this identity. This is just n choose k, right? So this is equal to x to the n plus sum k equals 1 to n minus 1, n choose k, x to the k, y to the n minus k, plus y to the n. Okay, but if I were to just put in k equals 0 here, I would get 1 times y to the n. So the k0 term is this term. So I can add that one back in. Also, if I were to put k equals n in, I would get 1 x to the n times 1. So that's that term. So this whole thing can now become k equals 0 to n choose k, x to the k, y to the n minus k. And that's your proof. Okay. Let's do an example. I have a little time. So here's an example. Well, we already have like the one with the binomial, so let's do another one. Let's say, let's let a equal the set of integers 1, 2, 3, ... up to n. Okay? Then how many subsets are possible of A? So how many subsets? Of A. And we'll include empty set and A itself. Well, there's there's different sizes, right? I could have a subset. The empty set there's no size, but there's n of size 1, right? And then there's n choose 2 of size 2. So the solution is just this summation of a bunch of combination things. So the size of A, which sometimes you write discrete sets the size like this, the cardinality, is equal to the sum, k equals 0 for the empty set, to n of n choose k. Okay? And we can now evaluate that. This is equal to the sum, k equals 0 to n choose k. And I could write this as follows. I could write this as just 1 to the k and 1 to the n minus k. Okay, but this is the binomial theorem in reverse. So going backwards from the binomial theorem, this is 1 plus 1 to the n, or 2 to the n. So for example, 1, 2, 3, there's 8 subsets. Okay, as you can check. All right, the multinomial coefficient we should still do, but we'll stop this video now.